So good evening to one and all. So today we are going to discuss, that is experiment number 3, about study of facts controller. We are going to study that one. Study of facts controller. Okay. So experiment number 3 you can consider. So this is actually, it will comes under section 2, that is the syllabus is that facts controllers, number 16. Okay, so before starting this one, the controllers and all the things, first we should have to know or learn what to mean by facts here now. So the facts means what we have to study that one. So consider this one as experiment number 3, study experiment. So that is the flexible AC transmission system we are going to call. Flexible AC alternating current transmission system, that is called facts we are going to call. So we have told I am telling the long form of facts here now actually. So can anyone tell the definition of facts in your project and all the things you may use using this controller? Actually, I'm not telling you are using, you may using the facts controller. That is, I think I don't know how many of you heard the name StatCom. Anyone have heard the name? Have heard the name, anyone? I'm asking to you people only. 25 members are present. Nobody is giving the reply here. See, actually, what do you mean by facts? Yes. It is actually a transmission system only. We are going to consider it is a transmission system. So this transmission system, it is incorporating some power electronics based devices, and the static controllers here. Now it is going to incorporation of power electronics and static devices to enhance the controllability, and to increase the power flow capacity here now, to increase the power transfer capability. That is called facts we are going to call them. That is called flexible AC transmission system here. This is incorporation of power electronics and some static devices or controller, which enhance the controllability and also increases the power transfer capability here. How it is going to increase the power transfer capability, I am going to tell you now. So here, suppose I will consider simple 5 megawatt load is there. Okay, 5 megawatt load is, generation is there. That is called generation. I will consider this is, and here we are using, suppose around the limit we are using, that is around 4.95 megawatt here. 4.95 megawatt load I am connecting to this one here, due to some, what is that one, sudden requirement, this 4.5 megawatt load will increases to 6 megawatt, Here 5 megawatt is there, 6 megawatt it cannot satisfy. On that time I have to use another 5 megawatt. I have to run that one to satisfy only this 6 megawatt here now. 6 megawatt for this one. So I have to 5 megawatt I will take from here, and 1 megawatt I have to provide here. No, but I have to run another 4 megawatt nobody is using. Then also I have to run this generating station here. Then also I have to run this generating station. So instead of switching on, instead of using this another the generating station within the existing system only, whatever the existing systems are there, here some losses will be there, I square or losses and all the things are there. Yes. So generation losses because of the various under voltage, over voltage, heavy loads and all the things. Based on that, by using a fax devices, it is possible to utilize this power effectively here. We can existing system only, we can increase the power transfer capability. We have to increase that. Okay. One more example I will tell that one. Suddenly you are going by a bike. You are going by a bike. Okay. You will feel that one. The petrol of your bike will be going to empty within, for suppose 100 meters. Within 100 meters, it is going to empty over there. Okay. On that condition, but the petrol pump is there 2 kilometers away. Only suppose 100 or 200 meter, your petrol is going to khatam, complete zero. So you will take the precaution that this 200 meter you can convert into 2 kilometers. How you are going to convert? Slope mein aaye to thoda band kar dete gaadi. Yes. Then suddenly you will do the acceleration and you will switch off the turn off the bike. Like that, by doing that one, you are going to reach this goal of 2 kilometers. Like that, by using this 4 megawatt, we have to utilize all 4 megawatt completely. Whatever the losses are there, we have to eliminate. By using the same within the existing system only, we have to ensure 100% utilization of the power transfer. 100% power transfer, we have to utilize that part. So for that reason, we are going to use the fax devices. We are going to use, that is, some controllers or fax controllers, we are going to call that. So fax is a incorporating of power electronics and static devices. I call that. So by using these advanced power electronics devices, so this ensures that it will give the dynamic characteristics. It is going to the operation, dynamic operation it is going to give here. So the fax devices are equally dynamic and static here. How the static we are going to use? The SCR and all the things we are going to use the switching devices here. Is there any rotating part here? No. So we are not going to use any rotating part, moving parts here. No. So the fax devices are equally static and dynamic. There is no rotating part or moving part in this one. For that reason, this is static. Because of using advanced power electronics devices, it will perform the dynamic operations. Can perform the dynamic operations. It is going to perform that. So it provides the controllability without compromising the security. For the existing system, it will increase the power transfer capability without compromising the security. The security will be same, but it can increase the power transfer capability. So for that reason, there are mainly basically 4 types of fax controllers are there. 4 types of fax controllers are there. So this is introduction, just introduction of fax we are going to call. So this is the definition. The transmission system incorporating power electronics based and static devices to enhance the controllability and to increase the power transfer capability. In the definition itself, it has 2 objectives over there. The definition itself, it has 2 objectives. First objective is to increase the power transfer capability. Second one is to, it should have to enhance the controllability over there. So that is, those are the objectives of the fax we are going to call that one. Next, controllers we are going to call that one here. Fax controllers here now. So controller of fax controller, fax controller. That is actually the fax controller. It is representing by a, I will draw the fax device representation here now. In a square box, we are going to keep one thyristor here. They are going to keep one thyristor. This is called fax controller. We are going to call that. This is a fax controller. Who is this Kedar? Someone is joining. Kedar. Who is Kedar? Just a minute. कोई है क्या केदार बोल के आपको ग्रुप में? Tell you that this is called the fax controller here. This device we are going to use as fax controller. We are going to consider this one here. So these controllers are classified into four types actually. The fax controllers, these are classified into four types. That is number one, that is called series controllers. We are going to call that one series controllers. Series controllers. Number two, that is called shunt controllers. Based on the connection of the controllers, based on the connection of the controllers, we have named that one shunt controller. And third one, combined series controller here, no? Combined series controllers. Combined series controllers. And fourth one is, that is called combined series shunt controller. We are going to use here combined series shunt controller here. So based on the connection of these fax devices, fax controller, if you are connecting in series with the transmission line, that is called series. If we are connecting in send, that is called send. If we are connecting two controllers, series and series, both series for two lines, that is called series controllers. For one line series, another line sent, that is called combined series and sent controllers here. So one by one, we are going to discuss now. One by one, we are going to discuss the different types of the fax controller we are going to discuss now. Okay, so I will remove this all the parts. I will take one by one. I will erase everything. But okay, so take this one as fax. So first one, I will consider the series controller. series controller I will consider. The fax controller symbol I will draw here first. Okay, this is the fax controller symbol here now. In a series controller, what we will do here, suppose one bus is there here now. Okay, one bus is there. Here, I will consider, I will take one line here now. So that line, so it will connect it to the load here now. So here, somewhere at in series with the line, I will connect the fax controller here. I will connect the fax controller in series with the transmission line. In series with the transmission line, I will connect the fax controller. Okay, what it is going to do, it is going to inject a voltage here now. That is voltage drop across this device is there. That one is injected in series with the transmission line here now. This is the line is there. So the performance, the operation of the series controller is, it is going to inject a series voltage in series with the transmission line. That injected voltage is in phase quadrature with the line current here now. Here, whatever the current is there flowing here now, that is in phase quadrature here now. So whatever the injected voltage is there or the connected fax controller, it is going to generate or consume only reactive power here now. The real power it is not going to consume and all the things. It is going to consume or generate only reactive power here now. How it is possible generate or consume reactive power only? Anyone? Someone has unmuted. Can consume or it can generate only reactive power here, because this device is, it may be the fax device, it may be what the, yes, anyone, can you? I'm asking to you people something. Because this controller is there, whatever we have added here now, it is going to provide only variable impedance. It may be inductive reactance, or it may be a reactor, or it may be capacitor here. The reactor is going to consume the reactive power, and the capacitor is going to generate the reactive power, or it is going to produce the reactive power here. Produce the reactive power here. So it may be variable impedance, it may be variable that is reactor or capacitance here, whatever the connected device is there here. So this one is the series controller we are going to call it. So what are the devices will comes under this series controller here? Static synchronous series compensator, that is called SSC, will come here. SSC will come here. TCSC, that is called thyristor controlled series capacitor, we are going to call that. TCSC. TSSC, that is called thyristor switch series capacitor. Just a minute. Where is stopped? TCSC. Next, TSSC, that is called thyristor switched series capacitor here. Now next, fourth one, GCSC, we are going to call that one GCSC. GTO, thyristor controlled series capacitor. So like this, so many devices are there. Thyristor controlled voltage regulators are there, phase angle regulators are there, GCSC are there, resistance also we can, reactor also we can control, that is thyristor switched TSSR also we can use that one. Thyristor switched series reactor we are going to call that. So SSC is static synchronous series compensator, that is called SSC we are going to call. Thyristor controlled series capacitor, thyristor switched series capacitor, GTO controlled series capacitor, and thyristor switched series reactor we are going to call here. So these are the devices we are going to study in the section B. That is this unit 4 we are going to study these all the things. These are the series controllers we are going to call this. So all the devices are series controllers. Second one, we'll go for the second one. The second type, that is called shunt controller here. Shunt controller we are going to use. Here the bus is there. The line I'm going to add here. Okay. For long kilometers we are going to add. This one I will consider as line, transmission line. Shunt means where we have to connect. It was series controller was there. Directly I have connected in a transmission line. Here in a transmission line directly I have connected. But for the shunt, it should have to connect at one point. It should have to connect. What I will do here, this is I will consider as a point, and I will connect one controller here. I will connect one controller. This one. This one is shunt controller we are going to consider here. Here the series controller, I told that one, it is going to inject a voltage in series with the line to control the current. By injecting a voltage, we have controlled the current here. And that injected voltage in phase quadrature with the line current. Here we are going to inject a current at this point here now. At this point, we are going to inject a current in transmission line here. We are going to inject a current at this point of the transmission line. That injected current, it may be variable reactor, capacitor, impedance, and all the things here now. So it is going to consume or generate only reactive power again here. It is going to consume only reactive power, or it can generate the reactive power. This injected current is in phase quadrature with the line voltage here. Is in phase quadrature with the line voltage here. So this is the definition of shunt controller we are going to call that one. The second one is shunt controller here. Okay. So the devices here we are going to use SVC. SVC we are going to call, and second one is STATCOM here. These are the main devices here. STATCOM we are going to call them. Anyone, can you tell the long form of SVC? Anyone, can you tell the long form of SVC? Yes? I'm asking to you people only. Hi again. Yes. So static SVC is nothing but static VAR compensator. We are going to call that static VAR compensator, that is old ampere reactive compensators here. Old ampere reactive compensators, we are going to call that. Just a minute. Committee has came, so I will resume soon. So sorry for the interruptions. So the shunt controllers are, there are SVC, that is static VR compensator. Another one is StatCom, we are going to call that one here. Static compensator here. Shunt compensator, we are going to call that one. Static shunt compensator here now. So in the SVC, what we are going to use? We are going to use thyristor controlled reactor, we are going to use here. TCR, we are going to call that one. It may be TCR, it may be TSC, thyristor switched capacitor, it may be fixed capacitor, it may be fixed capacitor. Okay, so like this, combination of these three are direct, we can use, that is called TCR, TSC, direct fixed capacitor. So it will produce the static VR compensator. What is the unit of which power unit? This is VR. Reactive power unit is VAR here, volt ampere reactive here. So these are the devices here. The third one I will erase this one. These are all the things. Otherwise, what I will do, I will erase this part. Series and series shunt controller we are going to discuss here now. We'll erase this part. So this is third one. This is fourth one. So series controller, series controller, and fourth one is shunt series or series shunt, we are going to call that. Whatever it may be, series shunt or shunt series controller. In the series, what we are going to do here now? I will take another line here now. Two lines, two controllers I am going to connect here. Two controllers I am going to connect here. So this one, what it is going to do here, this transmission line reactive power, it is going to compensate by it consuming or generating a reactive power, as well as we are going to provide one DC link here now. The DC link we are going to provide here now. Through this DC link, this AC is converting into DC and this DC is given to the here. We can, in between these two controller, the real power transfer is going on here. In between those two devices here now, controllers, here at the line here, it is going to inject a voltage in series with the transmission line and it is going to compensate the reactive power. Here also it is going to inject a voltage in series with the transmission line and it is going to compensate the reactive power. But the DC power link, we are going to call this one here now. So in between these two, it is real power exchange will occurs over that one here. So the series and series controllers, both real and reactive power compensation, they can do here. You can use that one. Similarly, series and shunt controller we are going to consider. Here shunt is there. I will use one series controller. I will use one series controller at this place. Okay. At this place I will use here now. Again here I am providing a DC link here. Again I am going to provide here now the DC link I am going to provide here now. The DC link I am going to provide here. So because of this DC link, the real power and reactive power, both the compensation will over here. Now we can do this. The in between individually it is going to inject a voltage in series with the line, and because of this one it is going to inject a current in at this point of the transmission line. So by injecting a current and voltage, they are going to maintain the reactive power. But through this one, these two are interconnected. This interconnected or interline system, it is going to real power exchange will be happens here now. So this will real and reactive power both we can compensate here now. So the example is that is called IPFC and UPFC, we can call that one. IPFC is interline power flow control. UPFC is nothing but unified power flow control here. So these are the four types of the FACTS controller here now. Series controller, sent controller, series controller, series sent controllers here now. So this is the study experiment. So all of you, you're already in the textbook, it is there. I will show here now. So you write the experiment, the write-up part you can complete by writing. Say, is it visible? कोई भी रिप्लाई नहीं देते सर. Is it visible बोल दिया तो भी कोई भी रिप्लाई नहीं देने वाला है. Is it visible? Okay, listen now. See, this is the fax controller actually. The controller diagram, yeah, using here. This is the fax controller. I will, in one phase, I will look at all the things. Okay, this one is better, I think. Okay, see here, upside. The fax controller, the symbol of the fax controller, this one. And the series controller, I told that one, series controller. So this one is the series controller here now, which is connected in series and injecting voltage in series with the transmission line. And this one is send compensator or send controller, we are going to call. At this point, it is going to inject a current here now. This current it is going to inject here now. And this one, it is a combined series controller. Here individually in a line, it is connected in series, and in between these two control, there is a real power exchange will be occurs over there. And similarly, the series and sent, that is in the coordinated manner, they are going to operate here now. So it is individually, it is controlling the, is nothing but injecting voltage in series with the line, and here current in series with the sent at this point line. At this point, it is going to inject here now. In between these two controller, there is a coordinated control is there. It is nothing but the real power exchange will be happens here. So for the devices, there are different devices are there. If I told that one for the series, that is AAAC is there. That is static synchronous series compensators. We are going to call C is this C means compensator. Remember that one. Okay. Then we are going to consider as TCSC. TCSC is nothing but thyristor controlled series capacitor here. No, it will not come here compensator here. No, it is a capacitor here. TCSR. TCSR, we are going to call that one. So R is nothing but thyristor controlled series reactor. We are going to call that one here. This is called series reactor here. So like this, here SVC is there. Here this one SVC, and here STATCOM is also there. SVC and STATCOM will come. Okay, STATCOM, and this one it is IPFC will come here now. UPFC will come here. So these all four types you write down. Study of fax controller here now. So write in the write up and complete this part. Experiment 3, that is study experiment, you take down and you can complete that one. So the fax has some advantages, that is nothing but power flow control. It can do the power quality optimum, we can increase the power transfer capability. Okay, stability improvement. So many advantages and disadvantages also there. Disadvantages is nothing but the cost is very high. Okay, so only you write that one, study of fax controller type, study of different fax controllers. These all the four types you write down. Okay, we'll stop here only.